something a little bit different tonight. This pile of junk boat anchor, no, it's a CB radio realistic, something I've had since about 2009. When I was going to the tip, a guy at the tip said to me, "Oh, you're interested in radios with the antennas on my car, and would you be interested in this?" And he gave me this realistic Navajo TRC 23C. Never owning a North American CB, I said, yeah, sure, yeah, take a look at that. And I knew that at one point in time I'll fix it up. Well, that's got to be 11 years ago. So here we are, realistic Navajo TRC 23C, just what I have in my hand here. I'm going to do a bit of research about it, find out what it actually is. But on the face of it, it's a 23 channel all crystal radio, so I'm probably expecting 26 slots of crystals in there. Just your usual rotary switch on the front there. All these things actually, these buttons move, they're not seized. It's got a volume delta tune, which is it's just a 3-position, negative, middle and positive, and squelch, which is a rotary control. Some kind of DIN, 5-pin DIN, like a push-on DIN for the microphone, and whatever the large jack plug is it 3/4 inch? I forget, not the 3.5mm anyway, the bigger one. And plastered all over this are these stickers that say, "Caution, to prevent electric shock, do not open, no user serviceable parts inside, pilot lamp soldered in place, refer servicing to qualified personnel, Japan." Now the interesting thing I find on this, on the actual serial number label on the back there, is that it says Citizens Band transceiver, quite as heavy. It's catalogue number 21-148, so we should be able to identify that from realistic Tandy information. AC 120 volts, 60 hertz, 25 watts. Now I got all excited thinking that's going to be a 25 watt CB. Wait now. DC 12 volts, negative ground. RF power output 3 watts max. Whew. Custom manufactured in Japan for Radio Shack, a Tandy Corp company, Fort Worth, Texas, by, get this, Hitachi. So a reasonable brand. Dock line approval number and a serial number stamped into it, 19741. Now this little white label here, I thought that might have held some kind of serial number information at some point, but I don't know. Anyway, the next thing we're going to do is break into this and have a look. Do a bit of research on the internet, see what we can find, and establish if there's anything inside and it's worth salvaging and getting back on the air or not. Who knows? Oh, so there she is. So a little bit of research about this realistic radio. I'm going to put in a TRC-23C and see what comes back. So nothing much there. Let's have a look. This is all eBay stuff. So this is Eric Farpoint Farms, very good YouTube channel. He looks at a lot of the older radios and restores them. I don't think we're going anywhere here. So the only other bit of info I would be interested to know is, when was this sold? How old is it? I'm guessing a 70s radio, but I'm not in the know, so I'm going to copy and paste that into Google again. And I'm going to put the word history after it, see if even that brings anything up. Christmas of 1973 was history. Realistic 23C. eBay. Manufactured by Hitachi, shares the same chassis as its brother TRC 24, sold by JC Penney, 71 to 73. How about that? There's got to be a collector's website out there that has all this info. So in absence of too much detail on the internet, I'm not too afraid to take this apart and have a look. The easiest thing I think at the moment is just to take this whole lid off with the 2 screws either end. And if we're looking at all of these screws, everything seems to be posi drive. Posi or Phillips, I'm not sure, but we can take a better look. Now, I am curious actually, apart from the corrosion on that connector I'm not too worried about, I'm actually interested in these pins. What they actually are. Obviously we're not just going to rock up and plug 120 volts onto any pin, nor indeed 12 volts. So we'll have a look inside and see where they go. So, operation take the lid off. Worried about displacing them. You can see from the top here that it has spent many years with a bracket around it. It's either bolted to a shelf or a truck or something, and you can see there was possibly a big sticker in this area, because the paint is much cleaner there in an exact rectangle. But anyway, moment of telling, let's have a little look, see what's in here. Well, that was easy enough. Used to be a piece of paper affixed to this, so there's probably some instruction or schematic. Oh, would you look at that? Hardcore old electronics with wires. And a bulb just sitting here out in the open, and here. That was their idea of backlighting, I'm guessing. Wow. And a speaker that's not actually up to the grill, a speaker that's set back by a good, what's that, 1.5 to 2 inches away from that grill. That's quite an idea. I wonder why they did that. A big old capacitor there, transformer. We should be able to work out what goes on from there. and we can see the primary wires there going in white and blue. I've got no clue what that is, other than live and neutral, I should imagine. So the 12 volt comes in on these other pins somewhere, and this little one comes down to here, so yeah, more than likely just straight red and black as it's shown there. So what's rattling? What's rattling? A screw. There we go, that's what's rattling. A little loose screw. Can we see where it's come from? No. So for 20, here's all the crystals. So this board here is stacked full of crystals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 there. Presumably there's some more on the back there as well. 14 crystals for a 23 channel radio. Don't know. We'll have a little look-see. We can work out how to dismantle that. So yeah, so basically that's the inside of it. Not too terrible. No dead animals. Could probably do with a little bit of a gentle wipe out with a moist lens cleaning cloth or something like that. That will just gather up some of the rusty dust. And then we'll take a better look to work out where to apply the 12 volts, etc. It should be pretty straightforward. He says there's a red and a black connected to the same pin here and a black connected to the other side of the cap. So again, we'll just do a little bit of dismantling and a look around to see what's what. So there we are, that's the startings of this project. So since the last little section, I've taken the base cover off underneath here and had a little kind of look around. Not really sure still where we're going with this, distinct lack of info on the internet. We'll just take a quick look inside for what I know, and then the next steps after this will be to apply some power to it. But I'm damn sure I will not be applying power to the 110 volts. We'll only be using 12 volt DC from a bench power supply. Okay, so let's see if we can go in. Here we go. So what I've discovered in looking at this is that this section here is actually all you need for a mobile radio, and they make it so you can see here the holes for mounting from the side. So this piece here would be all you need for, you know, just the mobile version, with the top and the bottom clamped on it to fit, and the big plastic handled nuts that go through the side and hold the bracket across the top. So yeah, that's your mobile radio. That was just crystals. There was, I think I counted 13, 14 on there. So some of them must be switched in twice with the rotary encoder. And on the power front, how can we do this? There's two wires here, red wires coming from the secondary of this transformer. They both individually run through a resistor and a capacitor, So that's, you know, the equivalent of a bit of a smoothing circuit for each half of the AC cycle. And then the output from that goes into this very large capacitor, which I'm not going to touch. I feel pretty sure that after 12 years it doesn't have any charge in it, but I'm not taking chances. And from there, the positive also comes back to this tiny transformer down here, and really I can't see what this serves in the circuit, because there's no primary or secondary to that. It's just a winding, and it goes to this terminal here with the white, and then a red comes across here to the red comes from this little terminal here across and into the radio. More than that I don't really know. So what I'm going to do now, knowing that well, there's a red that comes down from this connector here too, and it fits in the right places on the output, sorry, on the side of the resistor and capacitor network we just spoke about there. I'm kind of presuming that that's the 12 volt DC input, which then runs through, you know, resistor cap to go into this honking great resistor, capacitor here, which is going to be holding everything as smooth as you like for everything else to work. So it's just a big reservoir if you think of it that way. Okay, so yeah, next thing is grab myself some test leads, set the power supply up to 12 volts. I'm going to clip one onto the side here, although you can see the black on this strip line. There's a tag strip. So all of this actually, I think, you know, is basically the equivalent of a bridge rectifier. With some resistors on the output, a little bit of a timing circuit just to smooth off a bit. So yeah, into the powering it up, and then kind of making a decision if we're going to go anywhere from that. So I'm embarrassed to say that I've lost my Anderson power pole test leads and a whole bag full of different test cables that I've got. So we're going to be reverting to red and black banana plug crop clips, and just using these thin cables to get some voltage across. So looking at this, still not entirely sure. We know for sure the positive's going on there and the negative, but I can't see how the negative is hooked back into the radio, because it doesn't appear to come from this tag board. It must do somehow, but there we are. So I'm going to power up. I'm going to plug in. Only on 4.5 volts there. Too worried about shorts, etc. I'm going to crank that up to 12 volts, 11 point something, that's close enough. On the meter there, sorry, we're just 11.8 on the meter, and there we can just about see everything. That's good. So first of all, I'm going to connect the negative side down onto the pin with all the black cables, and the positive side we're going to go well, all of these, when I looked and checked, these are actually diodes. So this is in actual fact a bridge rectifier circuit, and the 12 volts from the outside wheel comes down to there, gets rectified and comes up to there. So I guess what we could do is just touch on there. Now here's where it's going to be a fucking big bang, or who knows. In actual fact, let's do this a different way. Let's clip this on down here first. So that's where the red would come from in the outside world, and we're going to connect it here and see if it draws any current off the bat. It might be a big flash and bang, and we came over. So it should draw quite a bit initially to charge up that honking great cap. So let's see. Yeah. There was a little flicker on the voltage there, but she's not drawing any current, and that is there. So let's click the voltage, the power switch on, and see what happens. Diddly squat. So no flash and a bang. Multimeter time. Where's the multimeter? So let's see if we got any voltage up to that cap. It is reading something, but what can we compare it to? And is that top pin there? Yeah, 11.8 volts. 11.84 volts. Okay, so that does have power in it, but she's not switching on. I wonder if we just check the voltage straight across there. Yeah, 11.83 volts again. So there is power to there, but where does it go after? Okay, so that part of it's the bridge rectifier. Coming out of this cap is this black lead into this other transformer, which I don't understand the purpose of, but I'm sure it's something quite logical. So I can check the voltage there, so we determined that was the black there. What voltage do we have down here? 11.83, yeah. So coming off of that cap is supplying through whatever that winding is there, back across this red wire to the radio, but she's not switching on. So yeah, there's simple red and white on the back of there, so I can check if there's a feed to the back of that power switch. Zero 0.3 volts on one side, 11.84 on the other. Okay, so let's flick the switch, see if there's anything coming out the other side. Yeah, so we got 11.8384 volts, whatever, coming through that switch. So we know that switch is working, providing power to that. That's as far as we can go right now. I'm guessing it's schematics time, or further dismantling to trace where that's going. Might even be a fuse on that board, who knows. But without further dismantling or schematics, we're not going to find out too clear. The good thing about this board is, let's turn the power off there, pull the red out, there we go. The good thing about this board is the legends very clearly marked with, you know, R's and C's, T's, etc. So somewhere around there we might find an F. If not, we are F'd, because unless I find some schematic, we're pretty much done on that. But I'm not giving up yet. Next part of the journey is probably some more internet research. That's as far as we're going right now tonight.
So this video, if you like it, comment down below a thumbs up.
Thanks for watching VA3SII. Bye.